In our previous video, we looked at a model that we could use to represent exponential growth. Let's look at a model we can use to represent exponential decay. Notice the model is the exact same thing as for growth, other than we have in parentheses 1 minus the rate, because I'm losing value, instead of 1 plus the rate. So everything still means the same. A is our initial amount, R is our rate as a decimal, and then T is our time. So let's take a look at how this will work with buying a new car. So our initial value of the car is $25,000. So I'll plug that in right here. That 1 is in parentheses. It's always there to represent us starting out at 100%. And then I'm losing value this time, so I'm going to subtract my rate. Now be careful, remember the percentage is not the rate. We have to change that into a decimal. And even though it's a decimal percent, it's not a decimal. So still divide that by 100 or move your decimal point over 2 spaces so that decimal, the number we're using in the model, is 0.042, and I want to raise that to 8 because I want to do this for 8 years. So that's what I'd recommend, just typing in your calculator. Just type in the full thing exactly as it is. I don't really know what 1 minus 0.042 is, but I don't really care. Just type the whole thing in at once. If you type it in piece by piece, though, make sure you're doing the exponent before you multiply by 25,000. Exponents come before multiplying in order of operation. So just make sure that you're getting the same answer that I do, otherwise you're typing something in incorrectly. So that car is going to be worth about $17,736, and since we're dealing with money, let's go 2 decimal places and get 34 cents. Again, make sure that you're able to get that answer. If not, something's been typed in incorrectly. Okay? Let's take a look at this other part of the problem as well and see what we're going to come up with. So this is a little bit of a different question. This time, I don't know how many years. That's the question. We want to know how long it's going to take for our car to be worth half of its initial value. Well, its value when we started was $25,000, so half of that is $12,500. So that's what I want to set my equation equal to. I want to end up with a car that's worth that much. So let's rewrite the rest of our model then to see if we can figure out a way to solve this. So we had $25,000 as the initial amount. We were losing value, so I had 1 minus 0.042. And then this time, I don't know what the years is. That's the question. So I'm just going to put a T or an X up there because that's what I'm trying to work out. Now, if you watched our last video about zombies, you know our 2 methods that we have at this point are either guess and check to find the answer, which I think is great. We can find a range of values. Or we could also graph this. We would graph one side as Y1, and graph the other side as y2. Now, if you're watching this as a review video, you may know about logarithms, and you may be able to solve this problem using logarithms. But for now, let's go ahead and switch over to the calculator and try both of those methods, the guess and check method and the solving by graphing method. So like we did in the previous problem about zombies, we are going to use the graphing calculator and a graph to answer the second part of the question, to figure out how much time it's going to take for the car to be worth half its value. If you want to use guess and check, you can certainly do that, but I think you guys know how to do that without my help, so let me just show you the graphing method one more time. So I've gone ahead and entered in y1. I've entered in one side of my equation. That's the car when it's worth half its value. And then as y2, I've typed in my model. Notice that x is an exponent. I don't want to make that a number because I don't know what the year is going to be, so leave that as x. Okay? I've set up my window already as well. I've gone from 0 to 25, x is years, so that's 0 to 25 years, and the 25 was a total guess. If it's not high enough, I'll have to go back and readjust it. The y, I'm going from 0 for what the car could be worth. I knew to start at 25,000 because that's how much it was worth, and it dropped from there. So I know I don't need to go any higher than that. So I should see an intersection point when I hit graph. So there's where the car is worth half its value, and notice it's halfway through the screen. And there's the car losing value over time. Notice it's starting to flatten out because it's decreasing exponentially or decaying, so it's starting to kind of not lose as much value over time. So there's the intersection point that I want to see. So let's go ahead and hit second trace to find this point. Select option 5, the intersect option, and then either arrow over close to it or just press enter 3 times. And you should find your intersection point right there. About 16.2 years is where the car will be worth half its value. Notice when I used guess and check, I came up with an answer of 16 and 17 years. Graphing is a way I can be a little more accurate and say about 16.2 years.